Hey everyone, I made this adaptive learning app that you can use in high school computer science classes. It delivers a computer science curriculum that aligns to national standards about computer science. At the start of Isabel's high school computer science curriculum, she is afraid to learn coding, and she also thinks that she can't do coding projects, but she's interested in all things tech. So Isabel is a sophomore in high school. She has no coding background, but she wants to learn independently. And she's in a computer science class that she's thinking of dropping out of because she sees that everyone's learning at a different pace and she's not quite sure she can get the content. When I thought of this app, I aligned the content to one of the standards, which is about algorithms. So I wrote here, level 1 is a beginning level, and level 4 is the highest level. According to the standards for teaching computer science, the first level is meant for ages 5 to 7. They model daily processes by creating and following algorithms, step-by-step instructions to complete tasks. And level 4, the highest level, is the high school range, ages 14 to 16. They're supposed to create prototypes that use their knowledge of algorithms that have been built up over the years. So Isabel starts this platform and she sees that the app brings her to a diagnostic quiz. She is given a challenge to complete with some multiple choice questions, and then it gives her a score at the end. And she saw that she got a 0 out of 3. So this places her at a point along the app. Then she starts learning some lessons about computer science, and all of these computer science lessons tie to a project that she makes at the end. The lessons change depending on whether she makes it through the formative assessments. So if she passes some of the quizzes, the practice quizzes, and she passes the actual quiz for the lesson, then she gets pushed to the next skill. The teacher too can track every student's progress. So Isabel is one point on this nodal map, and this teacher can see all of the history of where she traveled along this. So in that sense, it's a linear path that goes from skill to skill, and it is mastery-based learning with some branching pathways about how she wants to learn the content. And every student eventually gets to the mastery level of each skill. Adaptive learning is defined where you have different ways of using adaptive content. The first one is getting immediate feedback for a response that you put in while you're doing the lessons. The lessons should scaffold and help you learn content depending on what your skill level is. The next one is adaptive sequence, which means your pathway will be different from one student to another. And the last one is adaptive assessment, which means your questions might even change in difficulty as you go through the assessment. It can become easier or harder depending on how well you do. I use this as a baseline for making the app, as well as some learning theories about mastery-based learning. The idea of mastery-based learning is that you will go from skill to skill, and once you master one skill, you move on to the next. Kolb's learning styles are used as a basis for how to deliver the content. If the student doesn't understand one method of learning, the app will push them into a different method of learning, which is a different learning style. Kolb proposed that there's a range of learning styles based on active, reflection, concrete, and abstract. I use these learning styles in the app. Isabel's journey goes through these standards and skills, and the fact that the platform is adaptive also simulates one-on-one tutoring, which from studies from Kolb show that the impact on learning is much greater compared to a traditional classroom setup where there's one teacher and 30 students. Let's look at a couple of approaches that happen when Isabel gets a question or a quiz wrong. The first approach is an active approach. This is aligning to the active learning style proposed by Kolb. This is to fix a broken code example. The next one is a reflective approach. So the platform shows a side-by-side example of a piece of code. And the last one is a concrete approach where Isabel gets to see an example that aligns to the real world. These approaches switch depending on if Isabel gets the content or not.
T-minus 10, 9, 8.
So first you get put onto this page that gives you context for what you're going to build for this lesson. Going through these skills about the algorithm means you're going to end up building a tournament leaderboard for a school esports competition. The tasks are shown here, which align to the different skills of the standards-based learning. When you start off, Isabel is going to be given a diagnostic quiz like this, and you choose options here and eventually get a score. In this case, you get a 0 out of 3, which places you at the very beginning or early on with level 2. depending on how this platform is programmed. And then that's when the lessons begin. So the sequence would be lesson check with formative assessments and practice. Then it goes to the summative assessment with the quiz. And if it doesn't work, then you get through different styles of content delivery. Let's try this first one. So this is a lesson about sequences. I'm giving a formative quiz, which has adaptive content, which shows feedback on the screen. If I still get the formative quiz wrong, it's going to give me a different style from Kolb's teaching styles. This is a concrete style, which gives me a real world analogy. And then I'm going to get the summative quiz. I answered the first question correctly, and then the next question is going to give me a harder question because I answered the first one correctly. Let's say I got this next one wrong. It gives me a button that says try different approach, and then it goes into the next style of learning, which is reflective. Eventually, if you pass through all of this and complete the assessment, you get to the mastery level, which puts you onto the next skill, which is level 3. And then eventually, once you get to the end, you have an idea of how to build that project. On the designer view, as the instructor or the designer, you can see all of the students in your class and where they are on this journey. So when you click on a node, it shows you who's there at that node and their past progression to get there, as well as what kind of lessons they've gone through to be able to get there. To complete Isabel's journey into computer science, she feels that the app gives her a simulated one-on-one tutoring experience where she gets to have content that appeals to her and her sense of progression for learning computer science. She learns at her own pace. She receives different styles of content that sticks to her learning to promote, oh boy. To complete Isabel's computer science journey, she feels that the app gives her a one-on-one tutoring style experience with guidance that helps her learn computer science concepts at her own pace. She feels that the stylings of the content sticks to her and it promotes her engagement. She feels that it gives her real-time feedback that's valuable for her learning, and the sense of mastery and progression is clear in the system. She gets to create her own project by the end of it. In terms of future work, this platform is a proof of concept for teaching computer science concepts, which could be a supplement or even a replacement for how a student would learn computer science curriculum in the classroom. Larger considerations would mean LMSs and how to collect and store data and the privacy implications of that, and the usage of this platform by instructors.